Hello students, today we are going to discuss about one of the most important topic in our module 5, that is sewage water treatment. We know that sewage water, mainly it is the waste water produced from household activities, industrial activities, etc. So how we will treat the sewage water, or how we will remove the impurities, or how we will remove the contaminants present in this sewage water. We are going to discuss about this, that is sewage water treatment. Before that, this sewage water treatment, the sewage water that always includes two main processes, that is always two main processes always take place simultaneously inside this sewage water. That aerobic oxidation and anaerobic oxidation. Always in sewage water, both aerobic oxidation and anaerobic oxidation take place simultaneously. Let's see what are the main differences between this aerobic oxidation and anaerobic oxidation. So we can see the major differences between aerobic oxidation and anaerobic oxidation. Mainly, aerobic oxidation take place in presence of oxygen. It is mainly take place in presence of oxygen, where our anaerobic oxidation take place even in the absence of oxygen. Second difference, this aerobic oxidation is carried out by aerobic bacteria. Aerobic bacteria always carried out aerobic oxidation, and anaerobic oxidation carried out by anaerobic bacteria. Third difference, the aerobic oxidation products of aerobic oxidation are simple products like carbon dioxide, nitrates, etc. But the products of anaerobic oxidations are much complicated, that is products like methane gas, ammonia, hydrogen sulfide, etc. So aerobic oxidation products are simple and anaerobic products are methane, ammonia and hydrogen sulfide. Then fourth difference, that is aerobic oxidation, the products are simple and they are non-offensive smelling. Aerobic oxidation products are non-offensive smelling, and the bad smell produced from sewage water, it is mainly due to the anaerobic oxidation, because anaerobic oxidation products like methane, ammonia, hydrogen sulfide, all products are offensive smelling. So the reason for bad smell produced from sewage water is due to anaerobic oxidation. And anaerobic oxidation, one of the product is methane gas. So anaerobic oxidation result the biogas production. So in anaerobic oxidation, biogas is produced, where in aerobic oxidation no biogas is produced. Also, the last difference, energy released is more in case of aerobic oxidation, where energy released is less in case of anaerobic oxidation. So these are the main differences between aerobic oxidation and anaerobic oxidation. Now we can see what are the main steps that involve in sewage water treatment. There are main four steps in sewage water treatment. The first one is primary process. It's also known as preliminary process or preliminary treatment. Second step, that is known as settling process or sedimentation. And third one, we have secondary process or biological treatment. And the last stage, that is we have tertiary treatment. So sewage water treatment includes four main steps: primary process or preliminary process, settling or sedimentation, secondary process or biological treatment, and finally tertiary treatment. Process that is primary treatment or preliminary treatment. That is, it is mainly used to remove large solid particles present in sewage. We have large stones or large waste materials present in sewage water, which we can remove through this primary treatment. In order to remove these large solid particles present in sewage water first passes through this bar screens or mesh screens. We can see the bar screen, mesh screen pictures below. We can see in this slide, that is, bar screens or mesh screens work like a sieve. അരിച്ചെടുക്കുന്ന ഒരു പ്രോസസ്സാണ് പ്രൈമറി ട്രീറ്റ്മെൻറ്റ് എന്ന് പറയുന്നത്. നമ്മൾ സീവേജ് വാട്ടറിലുള്ള ലാർജ് പാർട്ടിക്കിൾസിനെ റിമൂവ് ചെയ്ത് മാറ്റാനായി ബാർ സ്ക്രീൻ അല്ലെങ്കിൽ മെഷ് സ്ക്രീനിലൂടെ പാസ് ചെയ്യുന്നു. അപ്പോൾ ലാർജ് പാർട്ടിക്കിൾസ് അവിടെ തടഞ്ഞു നിന്ന് പുറത്തേക്ക് വെള്ളം മാത്രം പുറത്ത് വരും. അതിനർത്ഥം ലാർജ് പാർട്ടിക്കിൾസ് സീവേജിൽ നിന്ന് റിമൂവ് ചെയ്ത് മാറ്റാനായിട്ടാണ് ഈ ടെക്നിക്ക് ഉപയോഗിക്കുന്നത്. ഓക്കെ, so this is primary treatment to remove large particles present in sewage by passing through bar screens or mesh screens. You will get a clear idea from this figure. That is, when we pass sewage through this bar screens or mesh screens, all the large particles is separated from sewage. So this method is known as screening, or we can say that preliminary treatment or primary process. Okay, first step in sewage water treatment, that is primary process to remove large particles through screening. Okay, second treatment, that is known as sedimentation or settling process. Sedimentation or settling process is a method to remove colloidal particles present in sewage. Colloidal particles can't be removed by the first process, primary process. They can be removed only using the second method, sedimentation or settling process. Colloidal particles can be removed by this sedimentation by adding chemical coagulant. Alum or aluminium sulfate is an example for chemical coagulants. For example, we have some water contain colloidal particles. Colloidal particles won't be precipitated or coagulated under the beaker. In order to coagulate this colloidal particles, we will add some chemical coagulant like alum or aluminium sulfate. When we add this chemical coagulant or alum into the sewage water or any water, all the colloidal particles present in water undergo coagulation process, and after some time, when we allow them to settle or allow them to sediment, we can see all the colloidal particles after coagulation precipitate under the beaker or under a tank. Okay, so we can separate water and colloidal particles by this process, sedimentation. So actually sedimentation includes to remove colloidal particles from sewage water. This colloidal particles can't be removed through primary process. It can be only removed through sedimentation. So in order to remove colloidal particles, we have to first coagulate or first precipitate them. So in order to precipitate or coagulate them, add some chemical coagulant like alum. So they will undergo coagulation. After coagulation, when we allow them to settle or when we allow them to sediment, all the colloidal particles precipitated under the beaker. So we can separate the colloidal particles from sewage water. So from this figure, it is clear that the first figure we have water contains some colloidal particles. When we add some chemical coagulant into it, it undergo coagulation, and when we allow them to settle or sediment, all the precipitated under the beaker. So we can separate the water and colloidal particles. This is the second method. So first process, that is primary process. Second process, that is sedimentation or sealing. This is the sedimentation tank. So we have huge sedimentation tanks are available. So water is filled inside these tanks and add some chemical coagulant. So this sewage water undergo coagulation, and all the colloidal particles present inside this water will be precipitated under these huge tanks when they allow to settle. This process is known as sedimentation. So huge sedimentation tanks are available for this purpose, in order to sediment or settle the sewage water to remove colloidal particles. The third process, that is secondary treatment. It's also known as biological process. It's the most important topic in this module. That is what is secondary treatment, or what is a biological process? Explain secondary treatment of sewage water. So actually the secondary treatment is actually similar to aerobic oxidation. It is similar to aerobic oxidation. So aerobic oxidation, we know that aerobic oxidation takes place in presence of oxygen by aerobic bacteria, and the products are simple product like carbon dioxide, nitrate, etc. Similarly, the secondary treatment always undergo this aerobic oxidation. It is mainly done by using some aerobic bacteria. Okay. So during after this aerobic treatment, secondary treatment, all the sewage waste, all the carbon contained in sewage waste is converted into carbon dioxide, and the nitrogen containing waste is first converted into ammonia and finally into its last form nitrates and nitrites. So final products of aerobic oxidation is carbon dioxide and nitrates, etc. For example, a sewage contains urea. We have urea with chemical formula NH2CONH2. This is urea. Urea after aerobic oxidation using some aerobic bacteria, all the carbon containing group in urea, that is CO, we have CO. So all the carbon containing group is converted into carbon dioxide. Similarly, nitrogen containing group present in sewage waste, that is we have NH2 in urea, is converted into ammonia first. Then this ammonia again split into nitrates and nitrite form. Okay. So this is actually secondary treatment. So secondary treatment or biological treatment is similar to aerobic oxidation, take place in presence of oxygen by aerobic bacteria. And during secondary treatment or biological process, all the carbon containing groups is converted into carbon dioxide, and nitrogen containing group first into ammonia, then into nitrates or nitrate. So explain with this using aerobic oxidation of urea, NH2CONH2. Final products after aerobic oxidation of urea, that is carbon dioxide and nitrate and nitrites. Okay. So how we will carry out the secondary treatment? We have well example for secondary treatment. It is known as trickling filter. This is one of the most important topic in our in this module. Trickling filters. Explain the working of trickling filters, or explain one of the aerobic treatment in sewage water treatment. Okay, so trickling filter, it is always remember, it is one aerobic treatment for sewage water treatment is the aerobic treatment. Trickling filter means it is the aerobic treatment in presence of oxygen by aerobic bacteria. Then what is the working of trickling filter? You can see what is trickling filter process. This is a trickling filter reactor. So first we can see what are the main parts, what are the main components of this trickling filters. A trickling filters always contains a rotating distributor. This is the rotating distributor. And there are some side arms here. It has two side arms. One side arm and second side arms connected to this rotating distributor. And this side arms contains some sprinklers through which water is fall down. Okay. And this is the filtering medium. Filtering medium is mainly made up of broken bricks, crushed rocks, charcoal, and dried leaf, etc. And this filtering medium mainly contains the aerobic bacteria. The filtering medium is the source of aerobic bacteria. So these are the main parts of trickling filter. And the bottom of this trickling filter reactor, we have a collection channel to collect the treated sewage water. Okay, so the main parts, which includes one rotating distributor, and connected to this rotating distributor it has side arms. Side arms contain sprinklers. And filtering medium contains aerobic bacteria for the aerobic oxidation, because it is a secondary process, right? Biological process similar to aerobic oxidation. Then what is the working of trickling filters? We are feed pipe, and through this inlet we fed water, mainly sewage water, in order to carry out secondary treatment. We fed sewage water into this trickling filter reactor. So this sewage water enter into trickling filter and move upwards through this rotating distributor and reaches into this side arms. And side arms contain sprinklers, so this sewage water uniformly falls down into this filtering medium through the sprinklers. So we are fed sewage water through inlet, they move upwards, and as this rotating distributor rotates, also this two side arms rotates, and this sewage water uniformly spread into this filtering medium. Okay, then when this sewage water uniformly spread into this filtering medium, they moves downwards. As they move downwards, the aerobic bacteria present inside this filtering medium carried out the aerobic oxidation of sewage, and after aerobic oxidation the products carbon dioxide and nitrates escape from this filtering medium, and the treated sewage water, it is collected under the effluent channel. So we can collect the treated sewage from this effluent channel. Okay, this is the working of trickling filter. Actually we are allowed to enter the sewage water through this inlet. They move upwards as this rotating distributor rotates. This two side arms also rotates, and this sewage water reaches into this two side arms. They uniformly fall down to the filtering medium through the sprinklers, and sewage water move downwards through the filtering medium. As they move downwards, the aerobic bacteria present inside filtering medium carried out the aerobic oxidation of sewage water, and the treated sewage water collected from the effluent channel. This is the working of trickling filter. Okay, this is one of the actual figure of trickling filter. Here we can see a rotating distributor and 4 side arms, and side arms contains sprinklers. Side arms contain sprinklers. During the working, as this rotating distributor rotates, also the side arms rotates, and sewage water is uniformly spread into this filtering medium, and this is filtering medium contains aerobic bacteria. They carried out its aerobic oxidation. After aerobic oxidation, all the products escape from the filtering medium. Carbon dioxide and nitrates escape from filtering medium, and the remaining treated sewage collected from the underground. This is the actual figure for our trickling filter. Also, we have another figure of trickling filter. This is our rotating distributor and side arms, 4 side arms we have, and each side arm contains sprinklers. Water uniformly spread into filtering medium. This is our filtering medium. Okay, then after secondary treatment, it is mainly carried out by using trickling filter. We have the final stage for our sewage water treatment, that is tertiary treatment. Tertiary treatment mainly include 3 main steps. First step is known as precipitation, second step is nitrogen stripping, and third one is chlorination. Precipitation is a method to remove the phosphate content present in sewage water. It is by adding calcium oxide. When we add calcium oxide into the effluent taken from secondary process, trickling filter process, when we add calcium oxide, all the phosphate present in effluent precipitated as calcium phosphate. So all phosphate content present in sewage water can be removed by adding calcium oxide. So they precipitated as calcium phosphate. This method is known as precipitation. Second one is nitrogen stripping. This is a method to remove ammonia gas present in sewage water. So in order to remove ammonia gas, we are using nitrogen stripping method, in which we have a series of bayfill plates are present. When sewage water passes through this series of bayfill plates, all the ammonia gas will be absorbed into this bayfill plate. So after nitrogen stripping, after we pass sewage water through this bayfill plates, the sewage water will be free from ammonia gas, because all the ammonia gas will be absorbed inside this bayfill plates. Third step, that is the chlorination, is one of the disinfecting method. So this 3 steps includes in our tertiary treatment. Precipitation, it is the method to remove phosphate content by adding calcium oxide. Second one, nitrogen stripping to remove ammonia by passing through bayfill plates. Chlorination, one of the disinfection methods. So sewage water treatment includes 4 main steps. First one is preliminary treatment to remove large particles by passing through bar screens or mesh screens. Second one, sedimentation. It's also known as settling process by adding chemical coagulants like alum into large sedimentation tanks. All the colloidal particles precipitated or coagulated under the sedimentation tanks. So after sedimentation, we can separate colloidal particles and water. Third step, that is secondary treatment. It's similar to aerobic oxidation. During aerobic oxidation, all the carbon containing products converted into carbon dioxide and nitrogen containing into nitrates and nitrates. Okay, one example for a secondary treatment, that is trickling filter. It's a aerobic treatment. And finally, we have tertiary treatment, includes precipitation, nitrogen stripping, and chlorination. This is about sewage water treatment. Sewage water treatment can also be carried out using some anaerobic treatment. Okay. Before that, we can see one flow chart for this sewage water treatment. That is, we have a raw sewage. First, this raw sewage undergoes screening. That is preliminary treatment, passing through bar screens or mesh screens. So all the large particles separate from water, and after screening it will undergo sedimentation process by adding alum. And after sedimentation we have trickling filter, that is secondary process mainly carried out by using either trickling filter method or activated sludge process. We have either through trickling filter or activated sludge process. Mainly in our syllabus we are mainly focused into this trickling filter method. After trickling filters, again we sediment our sewage water, and finally the tertiary treatment include chlorination, nitrogen stripping and precipitation. And we have the treated discharge. Finally we have the treated discharge. This is the flow chart diagram for our sewage water treatment. So trickling filter is one of the aerobic treatment for sewage water treatment. We have another method, that anaerobic treatment for sewage water treatment, that is known as UASB process. UASB process is upflow anaerobic sludge blanket. So trickling filter is the aerobic treatment for sewage water. UASB process is the anaerobic treatment in absence of oxygen carried out by anaerobic bacteria. What is this UASB process? So this is our UASB reactor. Uh, this is our UASB reactor. The center portion of this reactor is known as sludge blanket, and this sludge blanket mainly contains many granules. We can see many granules in this sludge blanket region. Okay, and this granules contains anaerobic bacteria. So anaerobic bacteria mainly carried out the anaerobic oxidation, and the sludge blanket contains the granules, and anaerobic bacteria are present inside this granules. Okay, and this reactor has one inlet and one outlet, and at the top there is a gas collector to collect the byproduct produced from UASB process, that is produced from the anaerobic oxidation, which is methane gas. So we can collect methane gas from the top using a gas collector. So one of the main advantage of UASB process is that as we treat our sewage water, we can collect methane or biogas as a fuel. So one of the main advantage of UASB process, it will produce biogas together with the sewage water treatment. Then what is the working of this UASB process? Mainly we fed the water through this inlet, and water moves upward direction. Hence the name upflow anaerobic sludge blanket, because water always flow in the upward direction. Water flow in the upward direction, and when they reaches into the center portion known as sludge blanket, this sludge blanket filled with granules, and anaerobic bacteria are present inside this granules. So this sewage water, when they flow upward, the sewage present in water undergo anaerobic oxidation, and after this anaerobic oxidation, the product like methane gas, which is escape from the sewage water, which can be collected from this top side using a gas collector. After the sewage treatment using this UASB process anaerobic treatment, the treated water collected from or collected through this outlet. So the working includes that is water enter through the inlet, they move upward, and when they reaches into the center, that is sludge blanket, granules are present, and granules carries anaerobic bacteria, and this anaerobic bacteria carried out the anaerobic oxidation of sewage. After anaerobic oxidation, the treated water will be collected through this outlet, and the biogas, that is the byproduct from this anaerobic treatment, which is collected using a gas collector. So one of the main advantage of this UASB process, we can collect biogas. Okay. So So this is about our sewage water treatment, one of the main topic in our syllabus. We discuss both the aerobic treatment and anaerobic treatment. Trickling filtering is the aerobic sewage water treatment, and UASB process is the anaerobic sewage water treatment. I hope all of you got a clear idea about this. Thank you.